So in this section, we're going to have a look at the statistics and data type questions that can come up. So mostly using graphs and interpreting the information from there. This first one is one of those classic questions where we have to put a tick next to all of the statements that are true. So let's read the information and see which ones are true. So the diagram shows a population of a town of 4,000 inhabitants. And we've got the males on the left-hand side here, the females on the right. And then we've got three statements. So let's check this first one. There are more females than males in the 0 to 10 age group. So this first bar here is our 0 to 10 age group. So if we go across to the females, using the scale as well, there looks like there is 1, 2, 3, 4 spaces between each of these numbers here, 200 and 300. So this would be 225, this would be 250, 275, and 300. So we roughly have about 250 females just below. So I'm going to do an estimate and say that's about 240. Whereas on the other side, you can see here we're getting closer to 275. So there is more males than there are females in this group. So that would be false. Okay, this is not true. It's the other way around. There are more males. The next one says there are more females in the 60 to 70 age group than in any other group at all. So if we go to the females over here and we go up to the 60 to 70 age group, which would be this one here, this is where we are finishing. So sometimes it can be helpful to visualize a dotted line. So if I just draw a rough dotted line going down, okay, not perfect by any means, but that's roughly 275. So we'll put here 275. And the question says, or the statement says, there are more females in this group compared to any other. And this is maybe where the dotted line helps as well, because even though it's not perfect, by going straight down, I can see that no other bar in this female group reached this. So this is true. This is the largest one for the females. And then the last statement says, there are more females in the 60 to 70 age group than males in the 20 to 30 age group. So here, we're actually comparing two different age groups. So we know already there's 275 females roughly in the 60 to 70 age group. But then if we go down to the 20 to 30 age group for the males, that is over here. And that is approaching 300. So this is false. It's the other way around. There are more people in this group in comparison to this one. So just work your way through the statement slowly one by one would be my advice, because that will help you check to see if each one is true or false. In the next question, we have a step graph. And one important thing to remember about a step graph is that when we have a colored dot all the way through, that is inclusive, okay? Whereas if we have a see-through dot with no color, that is exclusive. Because in this graph, we are being told the amount of calcium children need each day. But for someone who's 9 years old, for example, we're actually going to use this one here because it is inclusive. They need 1,000 milligrams. Something like 7 is a lot more obvious because that's right in the middle of this line. The question says, though, Jack is 18 months old and Peter is 10 years old. And we want to figure out how much more calcium does Peter need each day than Jack. So where we're saying how much more, that should tell you that we're going to need a difference. So we're going to find Peter's score and we're going to find Jack's score. And we've got to subtract Jack's score from Peter's. So Peter is 10 years old. So if we go up from 10, that's going to be this one here, which is going to be 850 grams. So Peter needs 850 milligrams. Jack is 18 months old. So again, another little tricky bit there. 18 months old is 1.5 years. So if we go up from 1.5 years, we're on this line. So Jack is going to need 750 milligrams. 850 milligrams minus 750 milligrams, which is 100 milligrams. And again, LANTITE style, because we are given multiple choice, but the correct option to choose is A. This question represents a Venn diagram question where we have lots of information, and when there's an overlap, that tells you they are doing both things at once. So this 7 in the middle, for example, tells us that they are the people who own a cat, a dog, and a fish, whereas this 31 over here tells us that there are 31 people who have a cat and a dog. But it says 158 people completed a survey relating to what pets they own. The information is given in a Venn diagram. And it says, given that 84 survey participants stated that they owned cats, what are the number of participants who owned both a dog and a fish, but not a cat? I have to admit, I've chosen a trickier Venn diagram question. So if I circle this set, is the fancy terminology, everything in this set needs to add up to 84. So at the moment, we've got 31, the people who own a cat and a dog. We have 29, those people own a cat only. And we have 7, these people own a cat, dog, and a fish. And you can use a calculator to add these up, but just for the sake of time, 9 add 1 is 0, plus 7, that's 17. So 7 here, carry the 1. And 1, 3, and 2, that makes 6. So at the moment, I've got 67, but I'm told that this set should add up to 84. So if I do 84 subtract 67, that will tell me that this number here must be 17. So if I borrow 1 here, 14 take 7 is 7 take 6 is 1, just double checking that it's definitely 17. So we've now got that list number is 17, but we're trying to look for the people who own both a dog and a fish, but not a cat. Those people are going to go here. So we're also told that the entire thing should add up to 158. So we're having to complete the Venn diagram first in order to help us get this final missing value. So the next thing we're going to do is we're going to add up all of the numbers that we can see now. So we have 29, 31, 17, 7, 42, another 17 down here, and a 12. And this is something where I will definitely be using the calculator to help me do. And when you total this on your calculator, you get 155. So at the moment, we have 155, but we are told there was 158 people who took the survey. So 158 take 155 is equal to 3. So this last bit here must be 3. And these are the people who own a dog and a fish because there's an overlap there, but they don't own a cat because we're not overlapping the circle which represents cat. So our answer is 3. And that is a tricky Venn diagram question. In most Venn diagram questions, you'll only see 2 sets, 2 circles. So if you followed this one, then really well done, because it is on the more difficult end. In this question, we have box plots, and that's another graph that I recommend that you know well. It tells us in this box plot that we have the lower quartile, the median, and the upper quartile. The question wants us to find the interquartile range for the height of the girls. So the interquartile range is the length of your box. So I'm just going to write that here. That's the length of the box. But it's the difference between our upper quartile minus our lower quartile. Okay. So we need to find what our upper quartile is, and then we need to subtract our lower quartile. So the upper quartile is here, which is represented by 150. Just be careful of the scale because this is going up in 2s. And my lower quartile is here, which is 140. So if I do 150, subtract 140, that tells me that the interquartile range is 10. So your range is the difference between the biggest and the smallest, but your interquartile range is the length of your box. And the clue is in the name quartile. you need to make sure that you're finding the difference of your quartiles and not just the entire fin. And in this last question, we are taking box plots again, but comparing it to those questions where you have to tick all of the true statements. So we have a box plot for girls and boys here. And let's start reading the statements and then doing the calculations so we can see which is true and which are not. So the first statement says the interquartile range of boys' heights was greater than the interquartile range of the girls' heights. So if we remember that the interquartile range is the length of the box, this actually makes things a lot quicker to compare instead of doing a lot of calculations. But if I look at the box for the girls, that goes from 140 to 150, like it did in the previous question, which is 10. Whereas the box for the boys, that's 142 to 150, which is 8. But where it's got the same scale, we can just tell straight away that this box is smaller in comparison to this one. And hence, so that is not true. And using the fact that the interquartile range is the length of the box will make that quicker for you. The next one says the range of the boy's height was greater than the range of the girl's heights. So remember, range is the highest, or in this case, the tallest, because that represents the biggest number, minus the lowest, because that's going to represent our smallest number. So it's not just the range of the box this time, it's the range of everything. And here we can see that the boys' biggest number is 160 and their smallest number is 136. So they have a range of 24, because if we do 160, take away 136, we get 24. Whereas the girls, their tallest is 156 and their shortest is 136. So they have a range of 20, because 156 take away 136 is 20. So let's just read the statement again. The range of the boys' height is greater than the range of the girls. Yep, that is true. It's 4 bigger. So this statement is true. And then the last one, it says the median value for the heights of the boys and the girls are equal. So the median is represented by this line here. So the median for the girls is 144, whereas the median for the boys is this number here, which would be 146. So that statement is not true. So when it comes to box plots, I would strongly recommend that you know what the 5 key details are. So you've got your minimum, your lower quartile, your median, your upper quartile, and your maximum. But remembering that the range is the difference of the biggest number and the smallest, so the start of the diagram and the end, and that the fact that your interquartile range is the length of the box will make questions regarding box plots a bit quicker for you.